Welcome to Electrostatics. This is chapter 32. Let's go ahead and get started. We're now into the electricity chapters with 32, 33, 34, 35 dealing with electricity. Oh, look, we got flying letters. Electrostatics. It involves the electric charges, the forces between them, and their behavior in materials. You know what gravity is. We've talked about it since basically the beginning of this class. Suppose you had a force acting on you that is 1,000,000,000 times stronger that could squish you to the thickness of a piece of paper. Well, you do have this acting on you. You also have a repelling force which is equally as strong in the other direction, so they cancel each other out. These are called electrical forces. Electrical forces are much stronger than gravitational forces. Does everyone know the parts of the atom? You remember these, the protons, neutrons, and electrons that you learned back in chemistry? So we know like charges repel, so two positives will repel each other, and opposite charges will attract, so a positive and negative will be attracted to one another. The same as two negatives will repel one another. Alright, I want you to read page 502. It's it's like two or three paragraphs on the pith balls on that little experiment. Make sure you read that. What is an ion? An ion is an atom or molecule with a charge. So whenever we talk about charged particles, it would be considered an ion because it has a charge. A cation would have a positive charged ion, and an anion would be a negatively charged ion. So cations and anions. Electrons move from place to place, or we sometimes say shell to shell. Remember when you talked about the shells of the different elements and things like that, all the different shells that were out there? They can even leave altogether and go to another atom or molecule. This should be ringing a bell back from chemistry. Outer electrons are the ones that can move from object to object. These are called the valence electrons because the outer shell of any atom is called the valence shell, and that's the ones that will either share electrons or they will leave completely or join. If you rub a rubber rod with a fur cloth, then the electrons leave the fur cloth and go into the rubber rod. What is the charge of the rubber rod now? Well, since the electrons went into it, it's going to be negatively charged because electrons are negative. What is the charge of the cloth? Since the cloth lost the negative charges, it is now positively charged. Rub a glass rod with silk, and the electrons go from the rod into the silk. So what is the charge of the glass rod now? Since the glass rod lost the electrons, it is now positively charged. What is the charge of the silk? Since it gained electrons, it will be negatively charged. Do you see how this works? Electrons are the things that are moving from place to place, and they are negatively charged, so they change what is charged. If they leave, what they left becomes positively charged. Wherever they go, it will become negatively charged. An object that has unequal numbers of electrons and protons is electrically charged. If it has more electrons, then it is negatively charged, and if it has more protons, then it is positively charged. If you have questions on this, please talk to me in class or come by before or after school. Coulomb's law. This is a pretty important one. This is much like Newton's law of gravitation. Remember that? We talked about this, that the force of gravity is equal to our g constant, mass 1 times mass 2 divided by the distance between them there, squared. We talked about this with very large like planets and different things like that, or we could figure out the gravitational pull between two objects. We did this last 9 weeks. Well, Coulomb's law works a lot the same way as this does. Coulomb's law says all of these are our variables for this. It looks like this. The force for this one is equal to a k, which is going to be a different constant. It's called the proportionality constant, or 9.0 times 10 to the 9th. Newton's meter squared divided by coulombs. That should be squared, not to the bottom power there. That's our k. The q's are charges. So you have a new variable now, this q. It's a charge, and it is used, it's one of the particles, and the unit is a coulomb. The unit is a coulomb, abbreviated with a C. The D is the distance again, like last time. To where, if I go back over here real quick, where we had G was our constant, over here, K is our constant now, where we had mass 1 and mass 2, we now have Q. we have the Q's here now. Q1 and Q2. So charge 1 and charge 2 instead of mass 1 and mass 2. And the distance between the charges. Alright, the greatest difference between Newton's and Coulomb's law is that Newton's law deals with attraction, whereas Coulomb's law deals with attraction and repulsion. So, we talked about Newton's law of gravitation. We're talking about two objects being attracted to one another. Two people, two planets, two if anything. Well, with Coulomb's law, because you can have positive and negative charges, if you had two negative charges, they would be repelling each other. If you had a positive and negative charge, they'd be attracted to each other. So that's the biggest difference between the two. Alright, conductors. Those guys that stand on trains and conduct. No laughter. Anyway, what are they? These are things that electrons can move about freely in. Anything that electrons can move about freely. Like metal is one of the greatest conductors. Any metals. Insulators. What are they? Electrons cannot move about as freely. They're not 100% kept out, but they don't move about as freely. So if you want a charge to move through something, you want to put a conductor in it. If you don't want it to move through something, you put an insulator in it. Alright, semiconductors can be made to behave as a conductor or an insulator. Silicon is a great semiconductor. Semiconductors are in all of our electronics. Motherboards and computers are layer upon layer upon layer of silicon. But they then put impurities of metals in them, so when a charge is placed in it, they can travel from place to place. All our circuit boards, things like that, are semiconductors. So it has both the properties of a conductor and an insulator. The last one is a superconductor. At temperatures near absolute zero, certain metals acquire infinite conductivity. That's like negative 273 degrees Celsius or 0 Kelvin. So you have to get it very, very cold, and then you'll have infinite conductivity. Once electric current is established in a superconductor, the electrons will flow indefinitely. So forever. Alright, induction. We're talking about types of how to charge things. Induction is charging an object without touching the object. Charging the object without touching an object. Ask me to show you an example of this. I'll draw it out on the board to show you what I mean. This is charged by induction, happens in thunderstorms. Clouds' bottoms are negatively charged. The Earth's surface is positively charged. So one's negative and one's positive. What happens? Basically the negative charge will shoot down to the positive charge from the clouds. Charging by friction, where electrons are transferred by friction from one object to another. This is like when you rub your feet on the floor and you become charged. You touch the door and you get shocked. That's charging by friction. And then charging by contact, when electrons are transformed from one object to another by direct contact. This is basically like just whenever you touch something and the charge flows from one to another. It's not really a shock. It's basically just the charge is transferring out of you. If you have more questions on these, I'll be glad to talk about these in class. Touch a charged rod to a neutral rod, it will transfer the charge to the neutral rod. And when I get the Van de Graaff machine out on Monday, I believe is when we're going to mess with it, I will show you more of this.